Good day, welcome to today's class. If this is your first time on this channel, click the subscription button to subscribe to our YouTube channel. And if you have been an errant subscriber, you're welcome. So in today's class, we'll be treating differential calculus. This topic has always been a problem to the economic students, not only the economic students, but those in the aspect of business generally. But today we'll be demystifying everything and explaining what we mean by differential calculus. Now, firstly, let's go. What do you mean by differentiation? You should have heard the word differentiation times down about differentiation. Let's go. Differentiation, according to what I have here, differentiation is the ratio of change between two variables. We are still coming back to what we mean by variables. But when you say differentiation, differentiation simply means the ratio of change between two variables. Okay, let's expatiate. Let's look at it very well. Now we have an illustration here. It said quantity of rice balls increases from 200 to 500 as the price of rice falls from 300 to 200. We all know the law of demand that as the price increases, the quantity tends to decreases. We all know that. So I have that in a table here. So quantity of rice both increases from 200 to 500. So from 200 to 500. As the price of rice falls from 300 to 200. So from 300 to 200. Imagine you are given a question like this, a table like this, and you are being told to calculate the differentiation. Now don't forget what we said earlier, that differentiation is just the ratio of change between two variables. Now let's go. The first thing you need to do is to calculate the difference in quantity. You want to know the difference because from the word differentiation, it's gotten from the word difference. Now, where is the difference in quantity? For us to get the difference in quantity, we say this is the new quantity and this is the old quantity. So we say the new quantity 500 minus the old quantity 200, and that gives 300. Now, difference in price also. Now we say, what's the difference in price? What's the old price? The new price. The new price is 200. The old price is 300. So when we subtract 500 minus 300, 500 minus 200, we have 300. 200 minus 300, we have minus 100. Now, how do we now calculate the differentiation? Just like I said earlier, I said it's the ratio of change. What is the change in quantity? That's the difference in quantity. 300 over the difference in price. That is what? Minus 100. So, in a nutshell, that's what we mean by differentiation. Anytime you hear the word differentiation, it means calculating the difference and placing it on top each other. So that's what I did here, 300 over minus 100, and I have minus 3 if you use your calculator together. Now, there are some terminologies you need to understand before you proceed to the complex part of differentiation. And one of those terminologies is what we call variable. Now, according to what I have on the body, what's variable? A variable is anything that changes with time. Anything that changes with time. Let's take a good example. A good example is price. Now, if you compare prices of 5 years back, 6, 7 years back, they are not the same with the current price at which goods are being sold. Now, what does that mean? That means that the price changes with time. The price of rice today in this particular year will not be the price, same price rice will be auctioned or sold in the next 8 years. So what does that mean? That means that with time, the price of rice will change. If this marker costs $100 today, in the next few years, there's probability that there might be inflation or deflation that will have made the price of this marker to increase or decrease from $100, is that to 200 or to reduce to $80. So that's what we mean by variable. Anything that can change with time. A good example is price, like I've said. Another good example is height, your height. When you're giving birth to, you're not the same height as you are now. Your weight, all these things are variable. Why? Because they changes with time. Now let's now look at the types of variable we have. We have usually two types of variable. We have what we call the dependent variable and what we call the independent variable. Now, when we say a dependent variable, what do we mean by when we see something is dependent, that means that let's take a look of this example. Look at, let's consider, oh, I have a good illustration here. Okay, let's look. They can also be called endogenous variable. So you need to know that dependent variable can also be called endogenous variable. So anytime you see the word endogenous variable, while independent variable can also be called exogenous variable. And so what are independent variables? They can also be called endogenous variable because they are determined by other factors. They are determined by other factors. Now, let me ask you a good question. From the table I have here, I said the price of a particular goods increased from 300 to 200, and that makes the quantity to fall from 200 to 300. The question is, what changes before quantity can change? There is something that must change before this quantity can change, and that is price. So, in that situation, quantity is a dependent variable. Quantity is a dependent variable. Why? Because quantity is simply depending on price to change before quantity can change. So whenever quantity or whenever one thing is depending on another thing before it can change, we call it dependent variable. If you don't call it dependent variable, you can call it endogenous variable. And a good example is quantity, because price has to change. Because from the law of demand, increase in price, not increase in quantity, leads to decrease in price, but increase in price leads to what? Decrease in quantity. So in a nutshell, that should tell you that price must first change before quantity change. So therefore, quantity is a dependent variable depending on price. That's what we mean by dependent variable. Now let's go. What do we mean by an independent variable? He said they can also be called exogenous variable because they are not determined by any external factor. So independent variable can also be called exogenous variable, and it's just simply the opposite of dependent variable. Now the question is, we all agree that quantity is determined by change in price, but what determines change in price? Obviously nothing, because price, there are a lot of factors that can make price to change, but for quantity to change, there must be a change in price. So therefore, quantity is dependent on price. Quantity is a dependent variable, while price can change, independent. Then we say price is an exogenous variable because it's not determined by any factor. So let's read through a summary of what we did. We said differentiation is the ratio of change between two variables. So I gave a good example. Price increasing from 300 to 200 and quantity reducing from 200 to 500. So when you want to calculate differentiation, you get the difference. The new one minus the old one, 500 minus 200, 300. Then the difference in price. New one minus the old one, you have minus 100. So the ratio of the two. So you have 300 over minus 100. And you have minus 3. Then this is the differentiation. This differentiation that is here, it can also be written as dy dx, or you say theta y or theta x. So whenever you see a sign like this, dy over dx, or this sign theta y over theta x, it simply means that change in y over change in x. Change in y, this is change in y, difference in quantity. 500 minus 200, 300, change in what? Then change in price, 200 minus 300. So whenever you see the y range, don't be confused, it's still differentiation, but we're just using it in short form. The y, change in y over change in x, change in y over change in x. But this is just a practical illustration. It's not even, you can't even see question like this in your examination hall. But you see question like this, you can do something like this. Y equals to 2x plus 3. They'll now tell you find y over dx. I'm going to solve something like this. Let's go. Now, example 1. We are given a question y equals to x, and we are going to find y dx. I said it earlier that in examinations, you are not going to see something like this and they will tell you to calculate differentiation or something. They are going to give you something like this: y equals to x, or more complex equations like y equals to x cubed plus complex equations like that, and I will tell you to find dy dx. Now there are two different methods we use to solve for dy dx. Now the first one is the first principle, and the second one is the general method. All we have of the general method. Now the general method is very much simpler compared to the first principle, but you have to know the first principle because there are some questions that they will just examiners will just make it mandatory for you to use first principle. Now let's go. How do we find dy dx using first principle? Now there's something I want you to know from this table that's up here. You should notice that there was a particular old price for this commodity. Then the price reduced from 300 to 200. Then that makes quantity bought to increase from 200 to 500. Now, from this that we are bringing y equals to x, we don't know. We know definitely that for dy dx, we also calculate dy dx differentiation. Definitely there must be a change. We must calculate change. But because we don't know the change, we say let's change in y be theta y. Now let me explain how I get theta y. From what we have here, we know that 300 from 300 price reduced to 200. So the change or the difference in price is simply 200 minus 300, right? So I'm going to get minus 100. But from this equation that I'm being given, I don't know, there's no way I can calculate the change in price or in y. There's no way. So what am I going to do? Just say let the change in y be theta y. I'll do the same thing for this quantity x. Let's change in x be theta x. Now you follow the process, you get it right. Now you now add your y plus your change, your x plus your change. So you say y plus what is change in y? Theta y. We assume that theta y should be changed in y equals to your x plus what is change in x? Theta x. Don't forget that what you were told to find. The objective of the question is to find the y dx. It can also be written as the y dx. Now, from what we have here, I have y plus theta y is equals to x plus theta x. And I want to look for theta y over theta x. What can I do here? I can simply bring this y to this other side. Let me make this dy to be on its own. So that we have dy to be equals to x plus theta x. Then this y is crossing the equality sign. It is plus invisible plus here. Then it is turning to minus. So minus y. Then we have dy equals to x plus theta x. And you go back to the beginning of the question. What is the value of your y? The value of your y from the beginning of the question is x. So anywhere you see y, you put x. So I can simply replace this y with what? X. So we have minus x. Now I have plus x here minus x. This cancel this. So I have my theta y is equals to theta x. Now if my theta y is equals to theta x and I want to find theta y over theta x, I can simply say for me to get theta y over theta x, let me divide both sides by theta x so that we have theta y over theta x. I'll say divide both sides by theta x so that we have theta y over theta x is equals to theta x over theta x. Then what we have here, theta y over theta x is equal to theta x over theta x, that's simply 1, just like 5 divided by 5, that is 1. So theta x by theta x is 1. So therefore, my dy dx, which can also be written as dy dx, is equals to 1. You follow the same process. Let's assume we have illustration. So let's assume we have something like this. Y equals to 2x. We are doing the same thing. Let the change in y be theta y. Let the change in x be theta x. The same process and the same procedure. So we do the same thing for this particular question. We say let the change in y be theta y. Then the same thing, let the change in x be theta x. Then I'm going to add theta y and theta x to both sides of the equation, just like we did here. Then I'm going to, let's go, we have y plus, what is change in y? Theta y equals to, now I have 2x, 2, then x plus theta x. Anywhere you see y, you add theta y, anywhere you see x, you add theta x, that's just it. So now we have y plus theta y is equals to, and I can expand these brackets. So I have 2 times x, I will have 2x plus 2 times theta x, 2 theta x. Now don't forget the goal or the objective is to find theta y over theta x. Now this is theta y and y on the left side of this equation. I can bring this y to this side of the equation so that we have theta y to be equals to 2x plus 2 theta x then minus y. And don't forget that this minus y, just like you change it to x from the equation, this minus y, it has a value from the beginning of the equation. The value of y is 2x. So anywhere I see y, I'll put 2x. So that we have theta y is equals to 2x plus 2 theta x minus 2x. Then what we have here, plus 2x minus 2x, then this can leave the equation. So I will have my theta y to be equals to 2 theta x. Now in this situation, I want to look for theta y by theta x. Let me just divide both sides by theta x. So I will have 1 and 2. So I will have divide both sides by theta x. So that we have theta y over theta x is equals to 2 theta x over theta x. So this cancel this. So I'm left with theta y over theta x is equals to 2. That's my final answer. Now still of cosmetric. Another question, y equals to 3x. We are going to find y dx. Find theta y over theta x. What are you going to do? Same process, same procedure. Let the change in y be theta y. You can just pause the video and solve the question yourself. Let the change in x be theta x. So I will add theta y and theta x to both sides of the equation. So we have y plus theta y is equals to 3 open brackets x plus theta x. Then I will have y plus theta y is equals to 3 multiplied by x, 3x plus 3 multiplied by theta x, 3 theta x. The same process, the same procedure. You bring this y to the other side of the equation. So that you have theta y is equals to 3x plus 3 theta x. Then this plus y probably minus y. You fetch the value of y and replace it. So you have theta y is equals to 3x plus 3 theta x minus what is y? Y is 3x. Then this can cancel this. So that we have theta y over theta y equals to 3 theta x. Then divide this by what? Theta x, because I want to look for theta y by theta x. Then we have theta x, theta x. So this cancels this. Theta y over theta x is equals to 3. That's our final answer. Now, we are going to be solving differentiation questions that has no power. It has no raised to power. Now let's consider the question that has raised to power and let's see how we solve them. Imagine we have y equals to x squared. How do you solve for this? How do you differentiate? How do you find the y dx? You know, the one we have been solving so far has no square. It is always 3x, 2x, and x itself. So how do you solve something like this? There is another expansion method I'm going to teach you, because expanding the right here in differentiation is quite different from the one you know in normal mathematics. Now let's go. For the same process and the same procedure, you have y plus theta y. Sorry for that. I'll say let the change in y be theta y. Then same thing, let the change in x be theta x. Then now we have theta y and theta x to both sides of the equation, so that we have y plus theta y is equals to x plus theta x. Sorry, y plus theta y is equals to x plus theta x then square. X plus theta x square, because it's having square. So you put the square into brackets and square. You should know something, that whenever you are dealing with two different digits that cannot be added, you need to put them in brackets. If you have something like this, x plus 3, you should always put them in brackets. Y plus 2, y minus 2, 3. Reason being that when you come across negative sign, it will always affect this and this. But if you don't put brackets, it will only affect one. So that is why it's always advisable that whenever you are dealing with two variables or two digits that can never be added, you put them in brackets. So that's why I've always been putting my answers here in brackets. So I have y plus theta y is equals to x plus theta x squared. Now, the thing we need to do now is to expand this bracket that we have here. How do we expand this bracket that we have here? Like I said I will teach you a different expansion that is different from the normal one you know. It's quite different, but you will get it right. Now let's expand this. Let's come here. Now I have x plus theta x squared, right? Now, x plus theta x squared. You should know that if I have a squared is simply a multiplied by a. If I have a cube, it's simply what? A multiplied by a multiplied by a. You should know that. Now, this one is in two places also. Just like a squared, a times a. So this one will also be in two places. So we have x plus theta x multiplied by what? X plus theta x. Now, let's do the expansion. X multiplied by x, that is x squared. Use this to multiply the 2. Use this to multiply the 2. X multiplied by plus x theta x. This is where the issue comes in. Now, this x multiplied by theta x multiplied by theta x, on a normal note should be theta x squared. But right here in differentiation, whenever you are multiplying x multiplied by theta x, you say it is x theta x. Why? Because we consider these two figures or these two to be one. So that's why we don't say it is equal to theta x squared. We say x theta x. You should know that at the back of your mind that whenever you're multiplying x multiplied by theta x, it will only give you x theta x and not theta x squared. So let's go. X multiplied by theta x will give us plus x theta x. Then theta x multiplied by x, same thing. Just like x theta x multiplied by x plus x theta x. Then theta x multiplied by theta x, that's plus theta x then squared. Now, we have x squared plus x theta x plus x theta x, that's what? 2x theta x plus theta x squared. Now, I've expanded what I have here. I've expanded it here. So I will replace it. Let's replace. So we have y plus theta y is equals to replace x squared plus 2x theta x plus theta x squared. Now at this point, we need to follow the due process. There is no need to panic because of the long equation. No. We follow the due process. The next thing we do is that we take this y, bring it to the other side of the equation, just like we have always been doing. So we will have theta y to be equals to x squared plus 2x theta x plus theta x squared, then minus what is my y? I know that my y is what x squared. So now we have theta y to be equals to x squared plus 2x theta x plus theta x squared minus what is my y? My y is what? X squared. So this x squared can cancel this x squared. So I'm left with theta y to be equals to 2x theta x plus theta x squared. Now 2x theta x plus theta x squared. The next thing we always do is to divide both sides by what? Theta x. So we say divide both sides by theta x. So when we divide both sides by theta x, we'll be having theta y equals to 2x theta x, 2x theta x plus theta x squared. Theta x squared. So dividing both sides by theta x, we have this divided by theta x, this divided by theta x, this divided by theta x. Dividing all through by theta x. So we have this theta x here cancelling this theta x, and this theta x here cancelling this square. Because you know that this theta x here is 2. So 1 cancel 1, we get 1. So we have theta y over theta x to be equals to 2x plus theta x. Now listen, whenever you solve differentiation and you get to this point, you get to the point where you have your theta y to be over your theta x. Any other theta x you have in the equation, you turn them to 0. Just like anytime you have your final answer, you're plotting your dy over dx, and you have another theta x in your equation, you turn it to 0. So you just say limit when theta x tends to be 0. So that we have theta y over theta x to be equals to 2x plus 0. Now we have theta y over theta x to be equals to 2x. So the final answer. Now, let's look at this example, the last example for this particular video. We have y equals to 2x plus 5x, and we have to find theta y over theta x. How do we go about it? Same process, same procedure, nothing has changed. Now we have, let's the change in y be theta y, right? That's how we have been doing. Let the change in x be theta x. So we have theta y and theta x to both sides of the equation. So we have y plus theta y is equals to 2 open brackets x plus theta x squared. Anywhere I see x, I'll change it towards x plus theta x. Anywhere I see y, I'll change it towards y plus theta y. And I said earlier that you always put them in brackets when they cannot be added. Plus another x here, I'll put x plus theta x. So that we have 5 open brackets x plus theta x. Then let's go. If I expand this, I've expanded this earlier. So you have y plus theta y is equals to 2 open bracket. If you expand this, you have x squared plus 2x theta x plus theta x squared into bigger bracket. Don't be confused. If you expand this, you have this. So 2 expanding on this, you have this plus 5 times x, 5x plus 5 times theta x, 5 theta x. Now, what's the next thing you do? You can expand this bracket here, this particular one. So you have y plus theta y is equals to 2 times x squared. You have 2x squared plus 2 times 2x theta x. We have 4x theta x plus 2 multiplied by theta x squared. That is 2 theta x squared. Right? Plus 5x plus 5 theta x. Now don't forget that the next thing is to bring this y, as you say, to the other side. It's just a particular process or procedure that you must follow. You bring this theta y, this y to the other side of the equation. So you have the theta y to be equals to 2x squared plus 4x theta x plus 2 theta x squared plus 5x plus 5 theta x. Just repeated everything. Then minus y. And you know that your y is what? 2x squared plus 5x. Just repeat straightly. Minus, put it in brackets. Why? Because they can never be added. Put it in brackets. Minus what? 2x squared plus 5x. Now, the reason I said earlier that you should always put two different variables that cannot be added into brackets is because if I have minus 2x squared plus 5x and minus 2x squared plus 5x, they are two different things. Why? Because this minus is only affecting this 2x squared. Why this minus is affecting the 2? This minus here is affecting the 2. So they are two different things. So here I will have, from this second equation, I will have minus 2x squared minus x plus minus 5x. But here you only have minus 2x plus 5x. You can say that they are two different things. So that's why you have to, you have to put two different equations or two different variables that cannot be added. You have to put them in brackets. So let's continue. We have my dy to be equals to 2x squared plus 4x theta x plus 2 theta x squared plus 5x plus 5 theta x minus 2x squared minus times plus minus what? 5x. Now what do you notice? That this can cancel this and this can cancel this exactly. Minus 2x squared can go for 2x squared. Then minus 5x can go for minus 5x. Cancel them out. So what are you left with? You have your dy to be equals to 4x theta x plus theta x plus 2 theta x squared plus 5 theta x plus 5 theta x. Yeah, I think that's right. 4x theta x plus 2 theta x plus 5 theta x. So what do we do? We divide all through by theta x. So divide all through by theta x, divide all through by theta x, and theta x. So what do you do? What do you have? You have theta x cancel theta x, you are left with 4x. Theta x cancel this square, you are left with 2 theta x, and theta x cancel theta x, you are left with 5. So theta y over theta x, let's come here. So theta y over theta x is equals to 4x, then plus 2 theta x, then plus 5, then plus 5. And I said earlier that whenever you have theta x in your equation, after still dividing by theta x, you tend or you limit the remaining theta x to 0. So you say limit when theta x tends to be 0. So you have theta y over theta x to be equals to 4x plus, anyway I say theta x, I'll put 0, 2 open bracket 0 plus 5. So theta x over theta y is equals to 4x, 2 times 0, 0 plus 5. And our final answer is 4x plus 5. Let's try, you can try 1 or 2 more questions yourself. Okay, you have this y equals to 3x squared plus 5x. 1, 2, y equals to 4x squared minus 3x, and over 3, y equals to 8x squared minus, why don't try this, y equals to 8x cubed minus 3x squared plus 5x. Yeah, try it. Put your answer in the comment section below. Thank you. Don't forget to subscribe to our YouTube channel. See you in our next class.